In this lesson, we are going to look at a couple of exponent laws. There are many exponent laws, and we're only going to look at a couple of them in this course. We've already talked about the zero exponent law. Anything to the exponent 0 is equal to 1. When we multiply numbers, the order in which we multiply does not matter. For example, 2 times 2 in a bracket times another 2 is the same as 2 times, and then we put the 2 times 2 in brackets. If you follow your bed math on the left-hand side there, we do what's in brackets first. 2 times 2 is 4. 4 times 2 is 8. Here we do what's in brackets first. 2 times 2 is 4. 2 times 4 is 8. It does not matter which order we multiply. So we usually write the product without brackets. It's just 2 times 2 times 2. How could we write this product as a power? So this is repeated multiplication. Our base is 2, and the 2 repeats 3 times. So it'd be 2 to the exponent 3. If I have a to the exponent m divided by a to the exponent n, so that's any number to the exponent m divided by another number, same number, same base, to the exponent n. Do you think we would call this a product or a quotient of powers? Well, product means we are multiplying. Quotient means we are dividing. In this case, the fraction bar means division. So this would be called a quotient of powers because we are dividing 2 different powers. One thing to note, in the grade 9 course, we will only be dealing with quotients of powers where the exponent in the dividend, which is the numerator, is larger than the exponent in the divisor, which is the denominator. And a cannot be 0. 0 has those unique properties that we will learn about later on in math. So for grade 9, the numerator exponent will be larger than the denominator exponent. When you take Math 10, you will learn that it can actually be different. The denominator could have a larger exponent, and that's a whole other law that will be dealt with. For now, the numerator will be greater or equal to the denominator exponent. Patterns arise when we multiply and divide powers with the same base. So to multiply -7 to the exponent 3 times -7 to the exponent 5, let's look and see what happens. -7 to the exponent 3 means -7 occurs 3 times. -7 to the exponent 5 means -7 occurs 5 times. Now, because the order of multiplication doesn't matter, we can remove the multiplication sign and just write them all together. We have a repeated multiplication that occurs 8 times. The base was -7, and it occurred 8 times. Do you notice the relationship between here to here? All we did was add the exponents. And this relationship is true for the product of any 2 powers with the same base. Very important, it has to be the same base. So if you have 2 powers with the same base that are being multiplied together, we can add the exponents. And this shows you why. You write them out in repeated multiplication, and you will see that we're just adding 3 and 5 of the same bases. So there are 8 of the same base. So here's our exponent law for a product of powers. To multiply powers with the same base, we add the exponents. So if we have a to the exponent m times a to the exponent n, our answer is a to the exponent m plus n. This works for every integer except 0, and m and n are any whole numbers. Now, very important, notice this was an a, this was an a, this is still an a. If we go back here, this was -7, this was -7, it's still -7. Lots of people make the mistake that they want to multiply the bases and write the answer as 49 to the exponent 8. No, the base stays the same. and it stays the same because of repeated multiplication. To divide, let's see what happens. Let's say we have 8 to the exponent 7 divided by 8 to the exponent 4. So we can write that in fraction form. 8 to the exponent 7 means 8 times 8 times 8 times 8 times 8 times 8 times 8, 7 times. 8 to the exponent 4, 8 times 8 times 8 times 8. Now, what happens when we divide 8 by 8? We get 1. So notice we scratch out those 8s. Scratch out these 8s because 8 divided by 8 is 1. 8 divided by 8 is 1. 8 divided by 8 is 1. So all we're left with on the bottom is 1. 1 times 1 times 1 times 1. In the numerator, we still have 3/8. Anything divided by 1 is just the number. So it's just 8 times 8 times 8, which is repeated multiplication of 8 to the exponent 3. Do you notice a relationship on how we get from dividing same bases to the answer? Hopefully you will notice we just subtracted exponents. 7 subtract 4 is 3. And that happens because we are able to divide out equal amounts. So whatever you have in your denominator will cancel out that many in your numerator. So our exponent law for a quotient of powers is to divide powers with the same base. And again, it has to be the same base so that we can divide them out to get 1. We subtract the exponents. So a to the exponent m divided by a to the exponent n equals a to the exponent m minus n. And in grade 9, we are going to make sure that m is larger or equal to n. Notice again, base is a, it's still a in your answer. Back here, it was 8 to begin with, it's still 8 in the answer. The base does not change. So let's try a couple. Let's look at the first one here. 6 to the exponent 5 times 6 to the exponent 4. These are same bases. They're both base 6. They are being multiplied. So we can just add the exponents. And our answer is 6 to the exponent 9. If you were unsure about that, we could demonstrate it. 6 to the exponent 5 means 6 times itself 5 times. 6 to the exponent 4 means 6 times itself 4 times. Multiplication can be done in any order. So how many 6s do we have? 9 of them. So it's 6 to the exponent 9. Second one, negative 9 to the exponent 10 divided by negative 9 to the exponent 6. Same basis. We are now dividing. So we subtract the exponents. We get negative 9 to the exponent 4. And again, we can show you that. Negative 9 10 times. I think I have 10 there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Divided by 6 of them. Now, let's divide. Negative 9 divided by negative 9 is 1. 1, 1, 1, 1, 1. We are left with 4. So negative 9 to the exponent 4. Why is it not necessary to evaluate these? I left it as 6 to the exponent 9 and negative 9 to the exponent 4. It's in the directions. Write each expression as a power. It does not say evaluate. We want it as a power, so that's a base to some exponent. So you have to look at your instructions. Here it says to evaluate. And evaluate means actually find the answer. But before we go through and find the answer, we can use laws of exponents to simplify this up. And maybe then it's an easier calculation. We don't have to use our calculator over and over again. In the first one, we are multiplying same basis. So we can add the exponents. 4 plus 7 gives us 11. Now we can evaluate that. Negative 2 to the exponent 11, it's an odd amount of negatives, so our answer is going to be negative. 2 to the exponent 11 is 2048. It was negative 2 times negative 2 times negative 2, 11 times. If we look at the second one here, we have multiplication and division of same basis. So let's simplify this up. Working left to right, we are multiplying same basis, so we can add the exponents. 2 plus 4 is 6. Then we're going to divide by 3 to the exponent 3. When we're dividing same bases, we subtract exponents. 6 subtract 3 is 3. Evaluate 3 to the exponent 3 is 27. If you simplify before you use your calculator, you're only dealing with one evaluation at the end. Whereas if we would have figured all this out, you would have gone 9 times 81 divided by 27. Now you would have had to try and figure out what 9 times 81 is. That might have taken you a little bit of work. 729 divided by 27. Now you have to figure out how to divide those, and you get 27. Whereas here you're working with smaller numbers and only one calculation at the end. So laws of exponents can really simplify your steps to evaluating. If we want to evaluate, we can use a calculator when necessary. All right, we have same basis. One set's being added, one set is being multiplied. Order of operations tells us we're going to do the multiplication first. So we're going to have 6 squared plus multiplying same bases means add the exponents. So 3 plus 2 is 5. Now, do we have a law for adding same bases? The answer is no. There is no exponent law. We actually have to do order of operations and evaluate these. So we have 6 squared is 36. 6 to the exponent 5 is 7,776. We add those two together, and you get 7,812. And that's what this is asking us. Why can't we add the exponents for all three powers? And the reason is there is no exponent law for addition or subtraction. You actually have to evaluate each side of your addition and subtraction and then put them together. Last one. So there's a whole bunch of brackets here, lots of the same bases where you have some multiplication, some division, some subtraction. So let's start with the brackets, because we want to simplify before we evaluate. So inside those brackets there, I am dividing same basis. So I am dividing negative 10. I can subtract the exponent. 6 subtract 4 is 2. Now, I am multiplying these together. There's no multiplication symbol, but when brackets are back to back, it means multiply. So I'm multiplying same basis, so I can add the exponents, and I get 6. Now I'm subtracting. I have no rule, so I have to actually evaluate each one. A negative to an even exponent will end up being a positive value. 10 to the exponent 6 is a 1 followed by 6 zeros. It's 1 million. Minus 10 to the exponent 7 is a 1 followed by 7 zeros. So it's 10 million. So now I subtract those, and I get negative 9 million. So there are exponent laws when you are multiplying and dividing same bases, but there is not when you are adding and subtracting. You have to evaluate those first.